I will kick things off. So my name is Dania. I'm the marketing lead here at SFC Energy, and I'd like to thank everyone for joining our webinar today. We're working here closely with our team today, as we've got Tyrell Conshu, our EFOI product specialist, Veronica Vengen, our product manager from Vaisala, and Kenneth Sampson, our service team lead and also field service engineer at Vaisala. So I'll pass it over to Veronica, and then we'll hear from Kenneth, and then we'll pass it on over to SFC's Tyrell. And then from there, we'll do a quick question and answer period after. If you do have any questions, feel free to just put your hand up or throw them in the chat. And then afterwards, we'll make sure that we get those answered. You can also throw them into the Q&A section as well. So with that, I will hand it over to you, Veronica.
Sounds good. Thank you, Dania. Hi, everyone. So just to recap, my name is Vengen. I am project manager at Vaisala. Been here about 6 years. A lot of that time has been spent in our renewable energy department, including LiDAR, which is what we're going to be talking about today. Oh, my screen is a little, there we go. So just some background on Vaisala. So we were founded 88 years ago in Finland, and we originally started with radio sondes and soundings. But over the years, we've kind of been pushing the envelope, pioneering and innovating weather technology. And today we do a lot of different things, everything from radar to road condition monitoring, lightning detection, and LiDAR, which is what we'll talk about today. Throughout those years and over time, we've kind of become a proponent for fighting climate change, and that's kind of where our goals are now, is giving our customers and the public, everybody, tools, information, data to understand what's happening with climate change, understand how to fight it, the tools we have in order to move forward. We are a global company, so this is just a little highlight of our LiDAR-specific factories and service centers. Our production, most of it takes place in our factory in France, but we also have a LiDAR factory in Shanghai and a number of service centers throughout the world. I am based in Boulder, Colorado Service Center. And this is just a little bit of background on the level of scrutiny that we subject our LiDARs to. Well over 1,000 third-party independent verifications against metmasts, which for a long time have been the traditional standard used for wind farm development. And we've put a lot of effort into showing, that our LiDARs can stand up to the traditional metmast. So just to get started, a little bit of background in case we have any folks who are perhaps a little less familiar with LiDAR in general and what it means. LiDAR stands for light detection and ranging, and there are actually two different types of LiDARs out there, pulsed and continuous wave LiDARs. Our systems are all pulsed LiDARs, so it means that they emit a pulse wave, a light wave, that goes out in 5 different directions, one directly, vertically above the wind cube, and then 4 in the 4 cardinal directions offset from that. So north, south, east, west, going out very quickly and kind of pulsing out. These light waves, when they are sent out, they hit aerosols that are in the atmosphere above the LiDAR. So it could be pollutants, sea salt if we're near the ocean, dust, pollen, any kind of aerosol in the air. When they hit those aerosols, they are bounced and scattered in a number of different directions. And some of the scattering, some of those light waves come back to the LiDAR. So that kind of shows you that illustration. They go out, they hit different particles at different heights, and then those particles are back scattered. And some of them, as you can see, don't hit the LiDAR, and the LiDAR doesn't see those, but some do come back to the LiDAR. And that's kind of where it gets a little complicated, but in simplified terms, the speed at which those particles come back to the LiDAR corresponds to the speed at a particular height. So what we're essentially doing is just measuring the wind speed at different heights above the LiDAR system. There are a number of advantages to pulsed LiDAR versus continuous LiDAR, as you can see here, a long list. I won't go through everything, but I'll just highlight the main ones that I'll point out. With continuous wave LiDARs, you're measuring different heights above the LiDAR one at a time. So let's say you want to start at 50, you'll go to 50, send out your wave there, collect that data, and then move on to 60. As you can imagine, that takes a little bit of time versus with our LiDAR product, you have one pulse going out that is collecting data from all the different heights. So not only is it taking, less time, so you could potentially be accumulating more data, more information, having shorter campaigns for that reason, but you're also getting the same resolution and accuracy as you would with any other at any other height. So same resolution and accuracy for each height that you're measuring at. In our case, you have up to 20 different heights that you can customize at. So you can do a standard every 10, 20 meters. And if you're thinking of a particular turbine hum height, you can customize it to be exactly where you're interested in. In addition, you have a lot of other benefits to pulsed LiDAR. You have no moving mechanical parts as you do with continuous wave. So of course, fewer potential points of failure with our systems. And there's a lot of benefit to just using that one vertical beam that I talked about in terms of our accuracy that you just don't see with the continuous wave LiDARs. But a lot of benefits here, and happy to discuss any more details if anything here catches your eye. So most of what I've been discussing here has been specifically about our WindCube, which is the first product that you see here, and the WindCube Offshore. So these are mostly targeted towards wind park developments, measuring the wind height at different, the wind speed at different heights above the unit. So the WindCube is designed for our normal onshore deployments, and the offshore is a little bit more robust because it's designed to be on a buoy where it could be potentially splashed by seawater and get corrosive for that reason. But if you apply the same kind of technology to a 360-degree motion or field of view, so we're not only measuring directly above the WindCube, but in 360 degrees around it, then you'll get our WindCube Scan, which is a lot of different applications, a lot of unique ways to use that, and that can actually measure several kilometers away. Versus with the WindCube, we're looking at several hundred meters above where the WindCube is. So around 390 is as high as we are currently getting with the WindCube. And then, of course, we have the WindCube nacelle, which is specifically designed to be mounted on wind turbines at wind parks for power performance testing and turbine control. And then, of course, our WindCube Insights fleet, where you can monitor your whole fleet, look at the data, present in different ways, run calculations that way. And so most of our deployments here, as you can see, happen in a wide variety of locations. On the left here, you see that WindCube on a buoy, but you also see here at the next to it, we have an installation in a very hot Middle Eastern climate. Above that, we have tropical conditions and even snow-covered tundra locations. So we've kind of installed in a lot of different locations, seen a lot of different terrains, and we've kind of been everywhere, to the moon and back almost. But in all of those situations, as you can see here, we're in pretty remote locations. So in a lot of the cases, we're not able to plug into grid power. There's not an electrical outlet we can just run an extension cord to power the wind cube. So we have to consider power and how we're going to keep our products, our wind cubes running in all of these locations when we're not able to be there 24/7. So there's a lot of different ways to do that. And one of them is SFC's methanol fuel cells. And I think that is one of the best things about our fuel cells, SFC's fuel cells, and our experience with them is the versatility and being able to install it in these very hot locations and then turn around and go immediately to a very cold location and know that it's going to hold up in both of those places. So with that, I will hand it over to Tyrell to talk more about that. But thank you everyone for your time and happy to answer any questions you may have. Thanks.
Awesome. Thanks, Veronica. I'll just get rigged up with sharing my screen here. Make sure everyone can see it all right. How's that, everybody? Thumbs up? Awesome. Thanks so much. All right. Well, yeah, thanks so much again for joining us. A little bit of background on SFC. We too are a worldwide company, except we have our roots in Germany. We have lots of offices around the world, though. There's new openings up in the UK. We have India, a little in the States now, and then, of course, where I am here in Calgary, Alberta, Canada. And then the fuel cell technology has been around for quite some time now. A bit newer here in Canada, only for the last 7 or 8 years, but we've paired up with Vaisala in the last while and had great success powering these kind of solutions, whereas remote off-grid solutions is typically what we pride ourselves in doing. Happy to move along here a little bit. So these are just a couple of samples of what we offer, more geared towards the wind measurement segment. So, or environmental monitoring in general even. On the left here, we see our smaller generation 3 units. These are 3 models, a 42 watt unit, an 82 watt unit, and a 125 watt unit. That would be the Pro 900, 1800, and 2800 respectively. And then the one on the right here is a 500 watt unit that we can do. We can parallel those. They're called the Pro 12,000. And generally speaking, between these kind of things, we can pair up solutions to as large or as small of a energy need as a customer might need. So a little bit about basics of how the EFOY fuel cell works. Lots of questions we get here. Lots of folks are understanding, like, can we hook loads directly to the fuel cell? The quick answer is no, actually. The way you best frame this in your mind is it's essentially a smart automatic battery charger. So what we're going to do is we're going to connect the fuel cell here to our batteries. So in a normal situation, let's say, your load will draw your batteries down. What we'll do is the EFOY will operate between a series of set points and run settings. So essentially, it'll watch and monitor the battery bank voltage. When we hit down to our switch on current or switch on set point, the EFOY will perform a charge cycle, take its time to charge things as much of as it can as a charge cycle, and then the load will continue to drain things back down. And then so on and so forth, the EFOY will carry the batteries through those set points. Now, ideally, we hybridize our system, that's how it's designed, so that solar can maintain these levels most of the time. Because I'm sure a lot of you folks are familiar with, solar is a great solution. It works a lot of the time, so we like to leverage that. But as we all know, there are things like snow, inclement weather. Here in Alberta, we get wildfire smoke all the time now, so that can inhibit solar as well. So essentially, if solar is not able to maintain the set points, the EFOY will kick on and run charge cycles intermittently when it needs to. So like I said, in ideal situations, the EFOY just sits back and monitors the system. Solar is able to do all of the charging itself. And then, like, yeah, usually we'll see more EFOY runtime hours in the wintertime where we see less sun, more snow, or even in a place's rainy season, perhaps, or like I talked about earlier, a little bit of wildfire season where we get some smoke. So yeah, any reason the solar isn't able to provide, the EFOY kind of kicks in and backs up that system. It essentially carries the system through until solar is able to once again pick up. So now, as the EFOY does run and accumulate hours, like any mechanical equipment or power generating equipment, it does have a lifespan. So we guarantee the unit for 6,000 hours, for example, the Pro 2800 there. And so to say, out of the box, maybe it puts out its 125 watts, but after its 6,000 hours, maybe we're down to about 85 to 90 watts of output. Now, in certain applications, certain equipment, maybe it only requires 50 watts to operate. So in that situation, that amount of derating hasn't presented a problem yet, perhaps. So you can keep running that EFOY until maybe 7,000, 8,000 hours when it's closer to that load in, load out mark. And at that point, maybe you'd look at replacing or refurbishing your unit. But essentially here, what we're trying to convey is as the unit accumulates runtime hours, the power output does slowly degrade. And a point to touch on too, that's not to say system runtime hours, that would be EFOY specific runtime hours. So in an example where the solar is carrying you all through your summer, the EFOY sits back and does not accumulate these hours. This is only during while it's doing run cycles, things like that. A quick example of how far our methanol fuel will go. So this is an example of 50 watt load. In this particular circumstance, there's no solar considered here at all. So on the left, we see two of our smaller energy containers, the M10s. That would give you 18 days on a 50 watt load. All the way to the right side, you'll see our larger energy containers, the MT60 liters. That would, 4 of those would get you 220 days alone. So as you could imagine, as we start to add solar into this system, we see those numbers of days or runtime way higher. Like the solar has a significant impact on the system, whereas we're able to rely more on that and less on the EFOY. So yeah, some points on why it's important to, or why we could hybridize systems, all the benefits we get from that. So you get a bit more reliability. So and like we talked about already, we know solar is great when the sun is shining, but we cannot guarantee when it will shine. There could be some overcast periods, a long rainstorm, a long blizzard set in. Regarding, depending on where, of course, your installation is, you might face your own unique challenges. Even like high tree lines or mountainous conditions could affect your solar input too. When you do pair a solar system with an EFOY fuel cell, you're able to reduce the footprint of your solar array and also your battery bank size. So with us, since we have essentially a built-in battery charger in the system, we don't need a large battery bank to carry the system. We actually can usually use around 2 small batteries for our system, because for us, all of our power is tied to the methanol fuel. So we have our cartridges of methanol in our energy solutions, or exterior, like we'll get you some fuel. And that's where all of our autonomy is hidden, not actually in the batteries. So if we size up a decent solar array, depending on your location, we have our batteries, and then all that power is stored in the fuel itself. And yeah, by doing that, we can generally get systems a decent amount of autonomy. Like a target autonomy for most of our systems is a year, depending on the load size and the location of their system and how good the solar is. Like I say, the target is to get just over a year. And when we can accomplish that, that generally means that in best case scenarios, a customer only has to visit their system 1 time a year to do a refuel, to do a quick check. Of course, people can visit it more often to check in on the system and make sure everything's good, dust off the solar panels, clean off any snow maybe. But yeah, the goal is a once a year visit. Depending on the size of load, like I said, or where you're located, or even the ability to use solar. Not everybody can use a large amount of solar. They have restrictions. Sometimes we're not able to get that year, but we're generally going to try to balance the system as best we can so we get a nice long lifespan out of it. A little bit of information on the methanol itself. It is extremely energy dense process. So much more energy dense than a battery bank per se. So with a couple of our methanol cartridges, we're able to get a great deal of energy behind that. So for example, one of our M28 cartridges, our 28 liter cartridge, get 31 kilowatt hours of energy in that. And then in the MT60, 66 kilowatt hours of energy. So if we're able to rely on solar a lot of the time, this methanol lasts a great deal of time, like we kind of discussed in the previous slide. Methanol is a hazardous substance, but we have our containers very well designed. They won't spill. They're perfectly sealed. You could take the cap off and push it over. It won't spill out. It actually needs to be coupled with the fuel hose and pumped out. And then they are certified safe for any kind of transportation, whether that be rail, helicopter, boat, back of a skidoo, back of a quad. We've not had any complaints or issues with people having to get the fuel to where it needs to be. And then to touch a little bit more on that, we have distribution centers all across North America, across Canada, and across the world where our other partners live. So yeah, supply to fuel has never been a big issue to us. We'll always be able to get it to you no matter how remote your solution is. To touch a little bit on remote monitoring, we offer the EFOI Cloud platform. If you are able to connect your unit to a cell network per se, or even just an internet connection, you can take advantage of the EFOI Cloud, which is available on a web-based browser or an app. And it'll essentially give you a snapshot of all the system's vitals that you'd want to see. All the vitals you're interested in, you'll be able to access, as well as alter some run settings if you have if you have the Platinum license. So what we'll see here on the right, you can see your remaining fuel levels. In the middle, you'll be able to see your battery parameters. And then on the left, you can see things like what the voltage at the battery is at, what it's currently doing, how much voltage or power it's putting out, how many runtime hours it's accumulated. You can see quite a bit of information here. And then the screen you would see before this one would essentially be a list of all the EFOIs claimed to your account. So you've got a nice overview of all the EFOIs in your fleet and what they're doing. So it's a really good way to check in on your systems. We find customers that are able to utilize this have a great deal of success. Now, in situations where you may not have access to the internet or a cell network, the EFOI can be pulled by Modbus TCP protocol, and we have a list of registers available. Essentially all the same information you'd want to know will also be available via Modbus. And we have a lot of remote customers who would set up radios and transmit essentially all their EFOI data via local radio network, and then connect at a hub and kind of read the data that way. So there are a couple different ways to go about gathering data from the system. We do have a bit of a broad portfolio of energy solutions. I won't touch on them all today, but I will touch on the ones that could be more centric to wind measurement. So the more common one we'd see for this application would be the Pro Energy Box 4060P. This unit here would house enough equipment for one fuel cell. So one of our 125 watt fuel cells. Inside this unit, we can have two on the right-hand side there, you'll see two of our M28 fuel cartridges. Underneath the EFOI there will be the batteries and a little bit of space perhaps for extra equipment. But you'll see in the lid of the system there is where our power distribution, our solar charge controller is. And then on the vertical strip there you're seeing on the right-hand side, that is the load distribution. And then on the very left-hand side in the middle there, that's the EFOI's operating panel, so you can operate the system locally. Now we can often see, we've dealt with some of the Vaisala wind cubes, and this unit has been able to take care of the system fairly well. The winter months when we push the heater into the system does push it up into the upper power levels that the unit can handle. But then in the summer months when things back up, the system is very easily able to take on the load of that system. If we ever had a need to add a second fuel cell to the system, well, we currently don't have a box solution to have two fuel cells. We do have a cabinet solution, and that is built with lifting lugs on top. This cabinet essentially could be built a set of feet. And with some installations, especially with wind measurement, we find that people want to deploy the system for up to 1 to 2 years. So essentially, to drop this cabinet off at location, you could hire a picker truck. I know a lot of places would have this service available. So you could pick it up, put her on the truck, drive her to location, and just pick it off the truck. And from there, we could have all of our auxiliary equipment hooked up, your solar hooked up, the wind cube hooked up, and then off you go for your year or two of measurement. This system essentially has twice the capability of the previous system. It has 2 fuel cells, room for 4 of the M28 cartridges, and then we can actually put a larger battery bank with this one as well. So essentially what we'll do is whenever we size a system for any application, a customer comes to us, we'd like to power this, this, and this. We will take your load information and take your location information. And the calculator that our German team developed will essentially give us this kind of system projection. The two values we pay most attention to are the two values on the bottom. That would be the operating run, the EFOI operating hours per year, kind of like I touched on earlier, and then the projected autonomy per year. So this system, as the example, has 451 operating hours a year. That's very good. If we could actually hit that, that shows us that this system would have a nice long lifespan. And then the projected system autonomy of 1.2 years, that's great. That would mean that we can get over a year of runtime on this. And that means that maybe you visit this system in the fall, ideally, just to make sure that everything's topped up for winter. And then it does most of its work in the wintertime. We can see that on the graph below. How I can interpret this graph for you folks is the blue line, that will be our load. In this case, it's steady all year. And then the yellow and the orange line. The yellow line on top is the average solar for the area. The orange line below that is our derated solar for that area. So what we want to do is we want to have a realistic view of how well solar is going to perform. Based on the location you give us, we're going to do our best, and hopefully you can help us too with the site conditions. So like if there's very high tree lines, we want to derate the solar a little bit. We want to be accurate in our assessment. If it's near a mine, there's going to be dust. If it's very far north, we want to make sure we account for some snow coverage, some ice buildup perhaps. Even things like if you're on the north side of a mountain and the sun's going to be obstructed for the best hours, we need to be able to derate the system so we get an accurate view of how it'll behave. Because we can't just walk into it thinking that solar is going to produce its peak value the whole time. It wouldn't be realistic. We want to make sure we're set up for success. So going back to the chart, you can see the months there from January to December. Essentially what we have here is with our derated solar compared to our load, this kind of setup is suggesting that from February till September, the solar should be able to cover our load no problem. Now, of course, that bars the odd long rainstorm or the odd smoke event, perhaps, like I said earlier. The EFOI will kick on and do charge cycles if that were to occur. But in this kind of projection, we can't really foresee that. We just base it off of the average solar. So what you can see here from October to January, that's when the EFOI is doing its running. So that 451 operating hours we see in the above stats, those are all going to be put on from October to January in this projection. So that is the EFOI's year. So when we talk about 1.2 years, that is just suggesting that the EFOI can make it through this winter, which is the year it sees. So yeah, like I said, we target 500 to 1,000 operating hours a year, so you get a decent lifespan. And then if we're able to, we try to get you over a year so you don't have to visit site too often. Because one of our big selling features in a lot of our installations, a lot of our applications is people aren't able to visit site very often, or it's very costly and inconvenient to do so, like a mountaintop installation or just a very, very remote installation. Visiting site more often is just more expensive than they ever want to consider. So if we can get them that year autonomy, that's best. So to kind of summarize a little bit, the main reasons you'd want to pair an EFOI fuel cell with a solar installation is you get things like more reliability in the wintertime or in bad weather conditions. The EFOI fuel cell itself is actually quite eco-friendly. It only emits the amount of CO2 as a person roughly breathes. So it is considered a green technology, and the more diesel generators we can replace, the better. We're able to get you a nice long autonomy on your system if we're able to hook up more and more fuel to your solution. We do add that remote monitoring capability if you're able to engage one of those two systems. And then, yeah, it is a fully automatic system. Once you set up and commission your system, we hit it to automatic mode. And from there, it should be able to, like we talked about in the first slides, it just monitors the batteries and the energy producing through those set points. And just make sure that it's able to do what it can. And essentially that's the best bits of it. So yeah, thanks so much for listening. I'll turn her over to Kenny and let him take it from there.
All right. Well, hello, I am Kenneth Sampson. I am a field service engineer and service team lead with Vaisala. So I get my hands on these products and get to install them out in the wild. Um, get my screen shared here. So I'm just going to run through a few examples of where we install these locations, weather, things of that sort, and just how easy it is to put these together as well. And then also talk about our cloud access, because our units have, the wind cube insights, and then we have the EFOY cloud, and working with both of those, that helps us keep an eye on the equipment remotely. So we can install these in remote locations with variable climates. This is, middle of winter. This is in the US, right outside of Chicago. Um, very, very robust in the cold weather. Sometimes our unit is rated to a negative 20 degrees Celsius. So if the temperatures drop below that, the internal temperatures, our unit will actually shut off. The nice thing is that the EFOY unit itself will actually keep running and charging the battery during those colder climates. So here's one, it was negative 40. The power supply was still charging the batteries. We had no solar during this time, and our unit was actually off. So I had to warm our unit up a little bit to get it running again, but we still had power. So yeah, so there's just very few parts and pieces to actually install. We have a frame for our solar panels here. We have some lightning protection, which you can see is the disconnect there. Everything came wired from SFC. So when I get in the field to put these together, it's very simple. I don't have to do a lot of wiring. Yeah, very, very easy. I think the hardest part is lifting the batteries, because they're pretty heavy. So you can see just 2 fuel cartridges. The batteries are sitting here in the bottom left, and then our EFOY unit here. You plug those all in and fire it up. So just some other views here of what the internals look like, what I'm dealing with when I'm in the field. So putting the batteries in, connecting those. There's only a few plugs and parts to plug into the EFOY itself. So that's very, very easy. There's also some customization to this as well for our specific product. So we have plugs that are custom fit to our wind cube. We also have internal here. There's a power regulator that will regulate the DC outgoing load, which is required for our unit. So also the startup, everything very, very easy. When you're setting up, you test a few things, run it through a few cycles, and make sure it all works, and you're good to go. So for the remote connections for our WindCube, we have WindWeb Insights, and we can keep an eye on our fleets and see what's going on with them. We can see some of the wind data in real time. Also, we can check on the left-hand side, you'll see the green box and the data availability. That'll tell us what's, on a high level, what's happening with our unit at the time. And in conjunction to that, we can also keep an eye on the EFOY itself and see how it's running, make sure we have plenty of fuel, it's charging correctly. We can actually customize our settings in the battery, and we can set those up with to work directly with our unit. And that's all I had. The other thing that's great too is the SFC tech support team is amazing. I've been in the field any time of day. I try not to do it, but in the evening sometimes as well. A couple of those guys will answer their phones and help me through any issues I have. So altogether, our partnership with SFC has been fantastic. We've been able to work through things and make sure that we have the right product for our units, and it seems like it just keeps getting better. So thank you for your time. That's all I have.
So right now is the time to ask some questions if you guys have any. If you do, please just drop them on the Q&A section down below and we'll read them and go through them. So no questions are coming up at the moment.
No questions yet. I can talk a little bit about, like Kenneth was talking a little bit about installation. Yeah, we try to make sure that when you get your energy solution, that when you go to install the EFOY inside and the batteries and things like that, all the wiring has been pre-done. So the system was running before it left our shop. So essentially what we do is just take out those components and make sure that when it arrives on site, you just got to put them back in and connect them. So it'd be connecting the batteries, installing the fuel to connect the fuel hoses. And the EFOY itself, like Kenneth's suggested there's only just a wiring harness to plug in, communications, and then power for the fuel managing device and communications. So it's quite intuitive. And then all that should be there available to you when you go to hook up your system. And of course, our service team is always available too if you ever require assistance. Something we try to hang our hat on is that we have 24/7, 365 support for anybody. Anybody needs anything, like any questions anytime, one of our service members is on call. If you simply call the 1-800 number on our solutions or available on our website, you will be put in touch with the first available service tech. And our techs are actually the same. So the same tech that maybe came to your site to help you start up your system would be the same tech you call here in our office. So the same guys who do our commissioning are the same guys who do our repairs. They've been around, they've been on our team almost since we've started with fuel cells. So they have a tremendous amount of experience between them, and they've pretty much seen it all. So it's really helpful having those guys in our back pocket, so to say.
And Terrell, we have a question over here. So they say you mentioned that the wind tube can usually be powered by the SFC Energy 2800 unit. Under what circumstances might this not be true? How cold, for how long, etc.?
That's correct. That was actually a bit of a slip of the tongue there. Normally, under most normal conditions, according to our projections as well, and Ken can weigh in on this for us too, the load can be covered by the 2800. As I mentioned, if the unit was to put on a great amount of runtime hours, it may show that the power the unit can produce can no longer quite cover the load in the wintertime, but that would be because the unit has ran its successful lifespan and derated a little bit. So under normal circumstances, we shouldn't have any problems there. And Ken, feel free to weigh in if you like on that.
The only time I've seen it not keep up was when it ran out of fuel and we couldn't get to it in time to refuel it. So yeah, I haven't seen them go offline because of cold. What is the cold rating for like the lowest temperature you guys are rated at to run?
That's a great question. Actually, we recently did, actually last year, it wasn't recent anymore, we did some cold chamber testing up here in a facility we have access to. We rate the Pro Energy box, so the 4060P we rate to -45, but we did take it down to -60 just to try it out since we had that capability. Taking it down to -60, the unit was able to still maintain a decent internal temperature and still run it's quite well insulated. And the exhaust was still maintaining a good temperature. Things were working all right. Now, luckily, we won't see -60 for too long and prolonged times, but yeah, we do see these installations in northern Alberta, northern Canada, where we typically operate. We're sizing some systems now for the Northwest Territories for a big mine up there, and we fully expect our solutions to be able to function all year, as many of the installations have.
Okay.
Great.
Well, if there is no further questions, we want to thank everyone for your time. And if any other questions pop up, please feel free to contact any of our sales team members.
All right. Thanks so much for your time.
Thank you.
Thank you.
Bye, everyone.
Bye.
Take care.
Have a great day.